you guys, and thank you for everyone who is here. I saw tons of people on the chat, and it's just extremely exciting for me just to see you all virtually. So this talk is basically kind of a look back. Microservices became kind of popular about 10 years ago. In 10 years, you can make a lot of mistakes, you can learn a lot of things, you can figure out some good patterns, some bad patterns, and you can get a glimpse of what's ahead. So this is going to be a shallow tour of a lot of small points that I've seen over the years working with a lot of companies that do microservices. Not going to go super in depth into every detail around each one of those patterns. If something super interests you, this is what the questions are about. And you know, let's get started. So looking back 10 years ago, we started using microservices. Most of us hopefully had a monolith before, so we didn't just start out with a bunch of microservices, but over time, as the service grew in complexity, the team grew, we started feeling it. We started feeling that it was hard to add functionality without talking to a lot of people, without stepping on each other's toes. Getting code reviews was a bit hard. Not everyone understood all parts of all the interactions. It was just harder and harder to do things in this large shared code base. So we decided to break it apart into microservices being independent units of functionality that a team can own, one or more of them, and can evolve it with their best understanding of the problem domain and deploy it based on their schedule and in the way that works really well for that team. So the keyword here is independent, and we'll keep coming back to it again and again. The goal here is to allow teams to move independently, and for that we have to do certain things with our code and interfaces to make sure this happens. For the most part, it worked really well. Like most teams that own microservices and ship them would, even though there are issues, they would not go back. They're happy to have ownership, this kind of ownership, to really control their fate, their deployment, their tooling, the way they do things, their preferred libraries, all those things. They enjoy it. We enjoy moving fast. We enjoy being able to ship when we're ready and not to kind of coordinate those big releases. These are like, we like microservices. By the way, if you don't like microservices, and there are a lot of people who don't, and I have my own second thoughts, this talk was extremely close to becoming why you should never do microservices, go all in on monolith, just save yourself the trouble. But we all have bad days. If you are not a fan of microservices, you'll have a lot of stuff to laugh about in this talk. You'll see a lot of things and you're like, oh, why those people just have all this complexity and not just have a monolith? Well, for the most part, because we like owning something independently and being able to make decisions about it. But it's not completely independent. We just broke apart our big functionalities that we give our business and give our customers into small bits. Obviously, each one of them does have to communicate to other bits of functionality in order to deliver what is supposed to be our product. So we have to have them talk to each other. Most of us end up, at least in the first iteration, using REST APIs. One, because every programming language will have an HTTP library, will have a JSON library. REST APIs are well understood. There are nice standards. Open API v3, you can generate things. It, most part, again, works pretty well. Makes debugging easier. You can always kind of open a bunch of listeners, lots of tooling around it. A pretty good thing. Always everything have downsides, but this is the common pattern. The problem is that as we went from a monolith to microservices and having them communicate, sometimes we accidentally build what we call a distributed monolith. What does it mean? It means that your microservices are not actually as independent as they should be. You know it because you don't actually get any of the benefits of microservices. You still have to coordinate with other teams. Code reviews still take forever. You still have to coordinate those big bang releases with 5 other teams. You still have trouble getting any new functionality in. If you're not independent, you kind of feel it in your bones. But because you're now microservices, you also have all the downsides of microservices, which means that you're building a distributed system. Debugging is harder. You have to kind of trace code between a lot of different services, which kind of gets complicated. So you don't want to be in a situation where you have the worst of both worlds. So this talk is really about patterns that I've seen toward being slightly less of a distributed monolith, reducing the risk that you will accidentally end up in this world. So problems that we've seen that could be a hint that you have a distributed monolith. One of them is that clients accidentally know too much. You actually expose a lot of microservices to the client. They have to call them separately. Clients are not something that you have a lot of control over very often, which means that anything that you expose to the client is extremely difficult to change, and you just lose your ability to kind of evolve things and based on your best understanding of the product. So this is one not great situation we need to avoid. The other not great situations that you sometimes see is that microservices end up knowing too much about each other. Not just that the client sees too much, they themselves see too much. What do I mean? Imagine that one of those circles is an order service, and let's say that another one is a validation service. In order to have kind of a nice order flow, the order service has to call the validation service has to call something else after that. And a lot of times you're like, okay, how much should the order service actually know about the business processes around validation? And like, what if there is multiple validation steps? What if the validation needs additional data? How does it work? So at some point you're like, am I drawing the right line between the two domains? Essentially, and a lot of times this is hard to get right. The other problem is that if a service fails, you need to have some logic. What do I do when I cannot call validation? Do I need to cache it? Do I retry? Is it okay to actually continue on and skip validation? In this case, I actually need to know what is the step after validation. You may have a lot of stuff that needs validation, not just orders, maybe insurance, maybe change of address, maybe change of payment. So suddenly you are in a place where some kind of failure handling logic, retry logic is suddenly all over the place. This is not great either. And then, I mean, making changes is risky always. I cannot say that I have the perfect solution to make every software change risk-free. This would be way, very, like, you know, if I could do that, I would probably just replace Musk as the richest person or something. But I can say that if you're not careful, you can make it harder than it should be. And a lot of this would be how to make changes a bit safer, and especially how to make changes in a way that does not have to be coordinated with every other service in the world, how to make backward compatible changes, getting test setup right, things that knowing who is affected, things along those lines. And then last problem is that we want to be independent, remember, which when we want to especially be independent to innovate, to introduce cool new things. And the main problem with the pattern of services calling each other is that in order to add cool functionality, I need to have someone call my cool functionality. So let's say I invented the world's best error handling service and I want a lot of services to call me because I handle errors better than anyone else. I need to go talk to him and say, hey, please use my service instead of what we've been doing until now. Guess what? Those other teams are also busy people. They have priorities. They have stuff to ship. Nobody told them that suddenly they have to start migrating to my service, and they may just say, sorry, not going to do it. We believe you it's better, but not going to do it. I don't have time. Maybe I don't believe you that it's better. Prove to me that it's better. The problem is that I don't have any way to prove it to them. Because if they don't call me, how can I show them that it's better? So you kind of get into this chicken and egg things that prevent you from really proving that you can do things better. And then the motivation to even try to do things better, which is really what we want in every engineering team, that they will continuously do things better and better, it just goes way down. And if you're in that situation, you definitely have not getting what you should have gotten out of microservices. So we're going to talk about patterns for that as well. So this talk is really about how can we do things better and not fall into those traps. In case you don't know me, very nice meeting you. I'm Gwen Shapira. Currently, I'm a founder of a kind of a stealthy startup. We're trying to make software as a service easier for developers to build and handle a lot of those anti-patterns for people. Previously, I was at Confluent, did tons of different roles there, did a lot of different roles in my career in general. I was a data architect, I was a consultant, I was a Kafka developer, product manager. I was actually in marketing for a while. I was an engineering manager. So I enjoy seeing the same problems from a lot of different perspectives. I was part of the Apache Kafka PMC, extremely proud of it, but no longer really doing a lot there. Wrote a couple of books, and I tweet a lot, which obviously makes me an expert about everything I say. So listen up. So first pattern is API gateway. Now, previous talks, when I could actually see people, I would ask for a show of hands who has API gateways. All the hands go up. I'm going to assume all your hands are up as well. Oh my God, you're actually all raising hands. This is extremely cool. So yeah, I'm betting that I'm going to see 200. Hey, be careful, don't crash Zoom. But so yeah, this is obviously extremely common way to prevent the clients from seeing every single microservice. It's obviously a bad idea that clients will actually know the internal structure of your architectures. None of their business, and you need to be able to change it without, like, this is the entire point. You should be able to move stuff around without them caring. Another thing that is maybe less obvious is that if suddenly a bunch of microservices are exposed to the open internet, you need to have security on all those services. And then you're kind of like, does every service have to have security just in case it gets exposed? Does everyone just unlucky enough to be close to the client have to handle all those security concerns? How do you distribute keys and permissions to all those services? It kind of gets hard. A lot of people solve it by having an API gateway, which will handle your authentication, authorization. It does throttling, which is super important when you're exposed to the internet. It just handles a lot of those concerns that otherwise a lot of different services would have to care about a lot. So as I said, it does lots of good things for you. It also may be a big deal, responsible for routing. So when requests hit it, they can be routed, if it's returns, it's routed here. If it's orders, it's routed over there. But because it does routing, you can do even cooler stuff. Like if the client asks for orders service V1, you talk over here. If it asks for order service V2, you talk over there. So this actually pattern allows you to upgrade your services and evolve, make even incompatible changes, and knows that you're not going to break clients because you have ways to handle it. And a lot of logging analytics in the API gateway is extremely useful because then you know who is calling what. You can start tracing at that point. A lot of good things. Problem is that sometimes it's too much of a good thing. There are some cases where you say, oh, actually, the gateway handles so much for me. It does so many good things. Let me talk to another microservices inside my company via my gateway, because it will route me to the correct place. It will do throttling for me, so I don't actually have to worry about how often I call it. It does all those great things. Let's talk to it. Obviously, this lands us straight back in monolith land, because now this API gateway is suddenly the choke point for a lot of services that a lot of other services need, and suddenly a lot of changes you have to talk to the API gateway team a lot. Hey, I'm doing this, can you please add support for that? The API gateway is down, now I can't even talk internally. It can get obviously complicated. It's the opposite of what we wanted. We want to be independent. We didn't want every single team to depend on API gateway team. So to deal with that, we just said, okay, let's put API gateways everywhere. Service mesh is one of those things that people who use it just take it for granted and don't think about it. Like it's like the air they breathe. And then there's the other half of the world who thinks it doesn't even exist and it's marketing buzz, and why does anyone ever do it? I'm going to explain it for the people who don't believe that it's a real thing. So API gateway, north-south traffic from out of your data center into first layer of services, more services, things come back up. This is the goal, and this is how we want it to be. Inside the data center, we have east-west traffic. It shares a lot of characteristics, as we said. You still need to do routing and throttling and all those things. So we need to solve this part. And the way we solve it is by taking what API gateway is essentially a proxy, right? So you take a proxy, you put it in a container, and now you run it next to every other service that you have. Same proxy. So it's really nice because this sidecar pattern, it's basically kind of provides you encapsulation, isolation. Because it's its own container, it means that it can actually, you could run the same code, unlike a library, you can run it next to every language. So I can write it in Go, and I don't care that some people have Java and some people have Rust and all those things. And it has one thing to do, which is manage traffic between all those services. So this is what it will, your architecture will end up looking like. You have all those services and a proxy next to each one of them. What does it do? More or less what the API gateway did. If you have any kind of authentication or authorization between services, it will handle that usually. If you have kind of routing, this is a really important thing. It does service discovery. It allows services to find out where each other lives, and you can move them around. It can even route between versions. It can do rate limiting, also important, and it can do logging and analytics. Sometimes this is extremely helpful to see who is talking to what and how much. Some examples of how it works. And we have ping service. It just moved to a new IP. It's still our order service, but it just moved. We have another service that needs to talk to it, the purple one. In the old world, when something moved, you have to push out a new configuration file or work with a DNS. DNS is still totally legit, but when you have a proxy, the way you write your code is that your purple service basically talks to itself in a way. Like it has a port that looks like localhost, but the proxy is listening to it. And then the proxy gets a request and say, oh, this is a request that should go to order service v1. Here it is, sending it over. And the proxy is responsible for knowing and discovering where everything lives. It basically acts as a mini local DNS. The other cool thing it can do, and this is something that I consider a huge lifesaver, as you know, error handling is hard. And a repeated pattern that has not stopped occurring on a regular basis in my 20 plus years in engineering is that you have a service that when it encounters a timeout or a delay or an error from another service, it retries and it retries and it retries. And every time it doesn't get stuff as fast as it wants. And usually people sometimes just like put ridiculously low timeouts, like everything always have to happen within 10 milliseconds, otherwise the world is over, but then they retry, so they don't actually do anything else in those 10 milliseconds they could have waited. Anyway, so they retry and retry and retry. If all those retries go directly to a service that is already having trouble, or God forbid a database, it can actually make the problem worse and worse. The database got a bit slow, but now everyone is retrying. Now it has this huge key of basically redundant requests. It's going to service all of them. It's going to get slower and slower and slower. It's going to crash. You may not even be able to log in and fix stuff because it's just struggling to keep up with all those requests. This is terrible pattern. We all know it's terrible pattern. Nobody ever did it intentionally, and yet we keep running into it all the time. So a proxy is really useful here because the proxy can be controlled centrally. It manages traffic. It can actually say, I'm not going to actually send all those requests over. And you can even be smart during an incident, tell it to slow down. It can basically protect other services from a misbehaving client, which is fantastic. And a big part of this magic, because you have all those proxies everywhere and you want to be able to manage them, is to have a central control plane, which is obviously a very common pattern for everyone who manages traffic. And this is what allows you to services to basically learn that something's changed IP, or learn that, hey, please do not send any more than this rate of traffic to this other service because it's already having trouble and we're dealing with it. So this central control plane is incredibly important part. Like if you don't actually have a service mesh, if you don't have a central place to manage all those proxies and all those patterns. Okay, we dealt with some problems with traffic. And now we'll move to talk about what is probably my favorite collection of design patterns for microservices. I used to just propose stop using request response and HTTP at all, just default to events. I'm now taking slightly less strong stance on it, but this is incredibly useful when applied in the correct places. So let's talk about the correct places. The thing this is trying to address is to reduce the risk of change and to allow you to put in new services to production with less friction. So very, very powerful when deployed correctly. So let's contrast the request response patterns with event-driven patterns. Request response, I'm sending requests to other services. Two types of requests normally for all of us secure S people. You have commands where you tell people what to do. Hey, validation service, please validate my order. Thank you very much. And you have the questions where you say, hey, customer service, what is the address of customer 537? I want to ship them a package. So those two things are normally what happens. And as we've seen, you need to take care to do it in a way that is not tightly coupled and in a way where errors are handled properly. In the event-driven world, you flip this pattern on its head. And so instead of telling people what to do and asking them questions, you tell them your state of the world, they listen to it, and they do what they think is right. This is extremely powerful when you do it, because this means that you are extremely independent. All you have to do is broadcast the state of the world as you see it to everyone. Hey, we have new orders here. Hey, this customer's changed his address. Hey, all those things are going on. And other services will figure out on their own what they do when they see those events. I'm an order service. I see a new order. I need to do X. I am a validation service. There is a new unvalidated order. I need to do Y. Here is a customer who changed their address. I'm a shipping service, but I should cache the new address because I may use it. So you suddenly go from services having those dependencies where I need to know how to tell others what to do. I need to know how to ask. I need to understand how they're going to respond, to I'm controlling my own destiny. I'm telling everyone what's going on, and everyone can do whatever they feel is right with their data. Amazing. So key thing to remember here is that the events that you publish to the world, they can be just facts about the world. Hey, customer changed his address. I don't know who needs to know, but something changed. And they can be triggers. Like, I'm doing it because I actually expect other services to do something with this information. Like an order created, I actually expect a lot of things to happen once I tell the world that the customer has created an order, and here are the details. So let's talk about buying iPads, my favorite thing to do, especially this time of year. This is the right time to get new expensive devices. So with REST, basically I have a web service. It calls the order service, submits an order. Order service calls shipping service, asks it to ship the order. Shipping service has to call the customer service. Hey, where does the customer live? Get a response, handle shipping. We know how that works. Obviously, the first thing we want to do is figure out what in the world do we do when the shipping service is down. The order service has to do something with this request. How about not just when shipping service is down? Every time customer submits an order, the first thing we do is is put it in our event stream, put it in our events bus. And now it's a fact of about the world, available to anyone who cares to listen to it. One of the services that cares to listen to it would be the shipping service. Now, the nice thing is that the order service is done the moment it wrote it to the bus. The shipping service could be down. We don't care. The order service does not have to care about what the shipping service is up to. When the shipping service comes back up, it can read all the orders that were accumulated in this queue and start processing them with its own logic. This is fantastic. If you need something to track it, obviously, if you don't recognize this is a choreography pattern, because all those services react, there's no central control for this workflow, but you can have a service that actually tracks state of events and who reads them and so on. So it's not like if you need choreography, it's not like it's completely missing. Sorry, if you need orchestration, it's not completely missing. But the nice thing is that if the shipping service is down for 5 minutes, an hour, nobody is going to freaking care. So why make the order service care about something that none of your customers care about? Nobody ever noticed an hour delay on shipping of an iPad, or, you know, some people do, but it's it's not, definitely not a common thing to worry about. So this is one really useful thing to have. The other really useful thing to have is that, remember that the shipping service needs to call the customer service every time it wants to ship something. This is why, I mean, we get the same data over and over and over again. Why would we do this? Imagine that instead the shipping service has its own small copy of the customer database. It doesn't need to know everything about customers. It doesn't need to know the credit cards, but it needs to know the address. So it has this small cache of customers and their addresses. And how is this cache maintained? Well, it listens to change events for this from the customer service. So customer service publishes, hey, customer mode, shipping service, like, okay, I have new entry in my database. This is fast because now shipping service queries locally. This is independent. If shipping service wants to change how it maintains its data, it doesn't need to talk to anyone else. And this is resilient because the shipping service and the database kind of go together. No database, no shipping service, nobody else is impacted. And no shipping service, we don't care about database. The customer service does not have to care. Shipping service doesn't care if the customer service goes down, doesn't care if the customer service changes the schema in its database. It's fantastic. So usually when I enthusiastically say that, we have two kinds of people in the world. Those who say, oh my God, you want to maintain a database for each microservices? Do you know how difficult it's going to be? Do you know how they're all going to diverge and cause complete disasters? And there is the other type of person who say, of course you need to do it because you do not have truly independent microservices without it. The first cold smell of you actually may have a distributed monolith is that all your microservices actually not just connect to the same database. Same database is kind of scary. What if it goes down? But it's not a disaster. The disaster if they all talk to the same tables and suddenly, who changed this row? What if I need to add a column? What if I need to remove something? Like, this is where you really get in trouble because the database becomes your monolith. On the other hand, if microservices have their own database, or even their own schema within the same database, if you actually don't feel like managing the database, life is better. Manageability of a database, you know, there's a lot of managed databases in the world today. I think I counted like 50 different ones just for Postgres at some point. They all have pros and cons, and they make some stuff easier, some stuff harder, but it definitely, running a database has never been easier. And because you have this shared stream of events, it's easier than ever to keep your own service in sync. All you need to do is whenever you come up, read all the events that you missed and update your database. It's not that hard. Make sure that you don't mark an event as done until you actually get the response from the database saying that your change is committed, and then you can say, okay, this is done. You have primary keys, hopefully, so you are not at a risk if you accidentally try to run the same event again and again. Nothing interesting should happen in your database, should be idempotent. And you get to have the data crunched and managed in just the way you need it for your service. This is something that almost every developer really wants, and they usually don't like fighting with other developers about the right way to crunch and manage data. Obviously, dependencies are reduced, latency is lower, you talk to something that is local. Amazing. We are absolutely moving in that way. When I gave this talk first time 4 years ago, people thought I'm insane. I tweeted about it about a week ago, and I had a lot of people say, oh yeah, of course, you cannot live without it. So we are moving in the correct direction. And the lesson here is that event-driven microservices are stateful. They maintain their own copy of state of the world, and they inform other services about changes to the state. Remember it, because in few slides, we're going to lose this state, and we're going to miss it, and we're going to look for it and wonder where the hell did it go. The other things that I want to point out about this pattern is that innovating is now easier than ever. Let's say that I have a world's best idea for pricing iPads. I used to work at Uber, and I know that as demand outpaces supply, I should raise the prices. So I can kind of have surge price. I want to do surge prices for iPad. These are always in back order, and why not just increase the price so people willing to pay more will get the iPads first. I'm a genius, and Tim Cook should give me a lot of money. Anyway, the pricing service is cool, but it's obviously really risky. And if I had to convince other teams to start calling my service, and obviously not for all orders, probably want to roll it out carefully, maybe in a really rich city first, just to make sure that it doesn't cause any unforeseen problems, they will have to do work. And we always say, putting things on other teams' agenda usually requires a lot of negotiation, a lot of proof, a lot of conversation, priorities, etc. What if I could do something different? What if all the orders and all the inventory and everything is in the stream of events? My new service just listens to those events and publishes shadow prices. And I do some analytics and analysis on what would those shadow prices mean. And now I can take my algorithm with the data and tell other services, hey, you can look at what would happen with my prices. You can run tests with it. It's already all there. There is no risk. The events are there. I haven't had to talk to anyone to get the information needed to build and test and validate my service. And in their spare time, they can experiment with trying to use my shadow prices in some cases and letting me know what happened. So I get to prove out my brilliant idea and collect the amazing annual bonus from Tim Cook. And I don't have to do all the convincing before I can prove that my idea is pretty darn awesome. Okay. One thing we did not talk about. We talked about the medium, how microservices talk to each other. Do they use the REST calls? Do they use events? What we didn't talk about is what they say to each other, the message, not the medium. So no matter if you use requests or events, you are sending and receiving messages. This is what messages normally look like. You know, JSON, a lot of fields, a lot of values, a lot of metadata, some stuff that you actually need to know. And the thing we're trying to address here is a risk of making changes that somehow manages to fly under the radar for a lot of teams. Even extremely experienced and extremely good teams sometimes ship services that break in pretty annoying ways that should have been more preventable. So here's the thing. I'm going to use events as an example. If you have REST APIs, more or less the same, you usually have a lot of people who care about your messages, your events. So, you know, you have something with user ID and a timestamp, maybe booking for hotels, and then you have a lot of things that listen to it. Maybe they need to write it to a database. Maybe they need to do some kind of marketing attribution. And all of them came to rely on the fact that your timestamp is of type long. And milliseconds since epoch. But you think it's not very readable. And there's actually a nice stringified readable standard for dates these days, ISO, whatever. Why wouldn't I switch to something more readable? Let's say that space and throughput are not really a concern. I can use more bytes and more characters. I do it because it is, why not? Would I know if it breaks anyone? Would anyone catch me when I do it? Obviously, everything is going to break. Every single thing, it's going to be an absolute catastrophe. I will need to not just roll it back, the events that I just wrote, I'll have to find a way to manually convert them to the old format in order to actually process them. This is going to be really tough change to roll out. I'm going to have to talk to all those other services, etc. Not great. And we're talking here about contracts. API contracts have been a topic of discussion for ages. Data contracts are now getting hyped. And in the event-driven world, we have schemas for our events. All of those are essentially contracts or APIs. And we need to treat them all the same. And same means we do for event schema exactly what you do for any other API, meaning you document it, you document the hell out of it, you have a plan on how to evolve it if you want to make changes, you have a plan on how to differentiate between breaking changes and changes that you can actually do without doing a lot of those version jumps and hops, how to communicate to other services about the changes that happened, how do you have them do graceful transitioning, all monitoring, all those things are part of owning APIs, whether you have events, whether you have REST, no matter, do the same darn thing. If you have events, common to use schema registries, Confluent has one. I'm not only working here, but I heard it's pretty good. It does both JSON and Avro and protobufs and a lot of other cool things. And if you are in the REST API world, there is a lot of open API tools. So you guys are all in good hands. Okay, now what happens when we take microservices to the logical extreme? We really like microservices, but one thing we don't actually like all that much is deploying and running a lot of services in production. You know, it's not that easy. You have to care about those pipelines, you have to monitor them, you have to think about scaling them, how many of them do you need, what happens when you have a lot of them, although you have to do load tests, like all those things can be pretty annoying. It's just work, and you know, for some of us, this is the work we love best. Like we are all in on all the best DevOps patterns. This is our world. For a lot of other people, they're like, I don't want to think about how the service is going to be deployed, monitored, scaled, etc. I just want to make sure my insurance policy pricing logic is perfect. We hear you. This is why a lot of us who absolutely love running services and making them scale and making them reliable and all those things, a lot of us basically went to work for companies where this is what they offer. So the company, and we feel like we're doing good to the world, and we ask everyone to move all your microservices to us so we can run it safely. The way it sometimes happens is the following. Serverless, sometimes, not always, happens in the form of a function as a service. This is why I say it's microservices in the extreme. What is more micro than a single function getting deployed independently? And the way function as service works is that those functions get events. They can get them from HTTP, they can get them from an event bus, they can get them from a freaking database these days. There is a lot of places you can get events if you use function as a service. The main thing is that your logic, all it has to do is take this event, process it, and respond. Meaning you have very pure business logic in the cloud. What the cloud does is take this function, put it in an extremely lightweight container, And every time you have an event, it's responsible to spin it up extremely fast. Usually it's like few milliseconds, and in a VM, and run it. This sounds good. You pay for every invocation of the thing. You pay for the CPU and memory you take while you run. But here's the cool thing. You do not pay for this thing when it doesn't run. If you have no events, it doesn't run, and therefore you do not pay. Compare it to normal microservices, where if the customers do not change their address, what will the customer service do most of the time? Maybe nothing. You are paying for those machines that maybe sit around, do almost nothing. So you can see why serverless becomes a very attractive proposition. The other really cool thing that happens is that because it's just an encapsulated function reacting to events, if there are a lot of events, your cloud provider doesn't have to queue them. It can spin up a lot of those functions to run in parallel. Fantastic. And note how well the incentives align. Let's say you have a lot of events that get processed you pay for them. Events that accidentally get dropped because of rate limiting, you do not pay for them, which means the cloud provider has every incentive to scale, to catch every event that you have, just go out wide. And as long as you have your credit card ready, you get all the scale you can take. They're actually extremely good at it these days. So, I mean, that's what happens when big companies have absolutely the right incentives. But note how familiar the pattern is. We get events, we consume them, we process them, and we produce a result. This is more or less what my event-driven microservice did. So one may think, oh, I can use all those patterns that I know and love. Well, kinda. What we're missing is our state, and the state is extremely important. We may have rules that we actually don't have hard-coded with rhythm for database. We may need to enrich events with calls to other services. We wanted to cache this. We may need to do joins, aggregates. We kind of need our local state. We cannot just have every event processed completely independently. Maybe I want to count multiple of them. This is a huge problem is something that prevents most microservices from becoming functions. So if you do have functions that need states, the way you normally do it is you use serverless database, as DynamoDB or serverless, one of those. It's slower because you have to call a database every time, like literally on every event. You cannot cache anything because it may go away. And you note all the places you pay. You pay for the time your function runs. You also wait for the time your function is waiting for response from database. You also pay for the database, for IOPS, for storage, for all those things. So it can be slower, and also the costs actually tend to add up unless you need serverless because you actually don't have that many events. I really missed my old pattern where I could have my local state. Yeah, I can have my own database on DynamoDB, but I actually really like having it locally. I really like having my function kind of continuously maintain it as it runs. It's a pattern that 4 years ago, I hope that stuff is evolving in that direction because it's so close, right? Because we already have those events and we can really do the right thing, like almost transparently. It didn't end up evolving that way. What we did end up is with better and better caches. And this is something that is slightly future looking. I don't think we're quite there yet, but the new systems that are getting shipped to production today, stuff like Venice, stuff like Rediset, a lot of things that are going on with Cloudflare, they're basically telling you, we have this really smart cache. It has the same APIs as a database, and you can tell it exactly what to cache, and it's always up to date. It's actually reading off the stream of events in the database, and you can have a shard, essentially, like a subset of your customers across many domains, or you can have a single domain, or you can kind of mix and match, or you can do, I only want to cache the most popular values, and I don't want anything unpopular. I'll actually go talk to this big database. And these days, the functions seem to trend toward talking to those. You get a lot of speed, especially if you go to the edge and those caches are distributed all over the world, but even in local things, you have this benefit. And you have the benefit of being able to shape data in exactly the way you want and not have to worry about exactly how it's maintained. Usually you can even write to it and it will handle the forwarding to the central data store and all the consolidation. So really, really cool thing. It doesn't solve everything that I wanted, especially since it's not, the cache is not running with my code, but apparently if you have a function, the thing you have to get rid of, like to lose, is that you'd never know when will the function start and stop. So maintaining a really local cache is becoming actually not that efficient. You have to eat the network hop, but it's okay. Networks in the cloud are actually getting better and better. So summary, toolbox for decoupling. We have our proxies, whether it's a gateway or the service mesh. It helps us have better ownership, less redundancy, shape the traffic patterns in ways that we don't have to really worry about harming other services because we don't quite understand how to retry correctly. We have the events together with the database per service and schema registry. It really helps us in de-risking changes and decoupling changes. And then we have serverless, which in some cases make things much cheaper and much easier. In some cases, it makes things much harder because you now have all those functions that do stuff to try to worry about. It's definitely extreme microservices if you see the need and the benefits to that, and you really, really hate deploying stuff and monitoring it. So that's about it. I'll open the floor for questions. Also, I love talking about it. So if you don't get your question answered here and I'm not answering on Slack, try me on Twitter, try my email. I love talking to people about those design patterns.
Cool, amazing. Thanks a lot, Gwen. So we have 3 minutes left, so maybe we can take a couple of questions. So one of the popular ones is, so the biggest issue my colleagues have with the event-driven systems is that it becomes problematic to just fix the data in a database. Any ideas how to address it?
I agree that it's harder to just fix the data in a database. I would almost say this is a feature and not a problem, in the sense that if you are in a public company with Sarbanes-Oxley controls and all that, you probably shouldn't be just going in and fixing data in the database anyway. You should have a very highly audited, highly controlled system for doing it. And since you have this system, you can do that in your event-driven way. This system should produce new events. So you cannot undo the things that you already had in the database. It's always maintained in the event store. This is a good thing. It's great. Auditors absolutely love the fact that all your mistakes are saved forever, because it means that nobody can do any kind of Enron-like shenanigans. I'm willing to bet that the FTX guy who managed to lose track of all his money, all his customers' money, he did not have this immutable events tracking every movement in the company. People just went and did shit in database and no longer know what's going on there. So produce new events, get your new changes in, they will go through the system, they will get updated database, and everything will be nicely tracked, and your auditors are not going to have awkward questions when your company goes under this kind of scenarios.
All right. So the next one is, isn't replication of data a bit risky in terms of consistency? Doesn't it violate the separation of domains principle?
Fantastic question. Absolutely fantastic. Yes, it is risky. This is exactly why I think there should be a single source of truth. And this is why this shared source of events that you're reading from and everyone else is reading from basically helps a lot with everyone is on the same page. Now, I agree, it is actually eventually consistent. It's not consistent. If you need hard consistency, you do need it on a database. This is an ACID database is still the best source of actual consistency. Events are great for the cases where the services are actually independent, so you don't need them to always be up to the millisecond read after write kind of thing. They listen to events, they do stuff, and they cache things like customer addresses, where if you get updated like seconds later or milliseconds later, it's not going to cause like, horrible downstream effects and inconsistencies later on. And regarding the separation of domains, I actually believe that this is the right way to separate domains, because even if you have perfect separation of domains, what are you going to do with data that you need from the other domain, right? Which always happens. We are building for that, right? This is why we have those interfaces. You go and ask the other service. So instead of going to ask the other service actually, in its own language, in its own domain, writes it to a bus. And you can read it, and you can apply your own domain logic and domain rules to whatever you see. You can say, this is information I need, this is information I don't need. Yes, that domain enjoys formatting dates this way. I need things in a slightly different way, and I need the number of business days, etc. You can crunch, have it exactly the way you need. I feel like this is actually the right way to separate domains, versus just keep calling whoever is responsible. But if you see problems with it, definitely I would love to discuss it. It's just my experience with how I do the domain driven.
All right. Perfect, Gwen. Thank you very much. So there are still like questions in Slack, so just please then go and check them.
Be right there.
Thank you very much for your talk. It was really great.
Thank you, guys.